Hello, my name is Suraj Jami. My registration number is 18BEC0281. Slot is C1. Serial number is 18. And now I am going to explain my COA assignment, Computer Organization Architecture Digital Assignment 1. So previously in the video, I explained the how to draw flowcharts in the draw.io. Okay, so in the DA1, we have to select a microprocessing element, microprocessor, controller, or IP core from any vendor of our choice to answer the following questions in the digital assignment 1. So I have selected the microprocessing element is PIC32MM0256GPM064 from the vendor of microchip. So this is the data sheet of the microchip family. Sorry, PIC32MM0256GPM064 family. This is the whole data sheet. This I have referred for answering the questions of digital assignment 1. So let's go to the digital assignment 1. For the first question, it was asked to draw the clear block diagram of microprocessor or controller IP core selected. So this is the diagram I drew using draw.io. So this is the timing generation block diagram. This is the precision band gap reference. We have primary oscillator. This one secondary oscillator, dividers, PLL. So according to that, we have this thing, power up timer, oscillator startup timer, reset, switched off timer, brownout reset, voltage regulator, precision band gap reference. Okay, this is a whole block diagram for uh, the of the microprocessor controller which I have drew from draw.io, which it was available in the data sheet. So yeah, this is the bus matrix. We have the flash line buffer, RAM, peripheral bridge. This is the 64-bit wide program flash memory and the flash controller. This goes to this thing, which gives the input IO change notification, timer 123, MCCP 123, SCC 123, etc. Okay, so these are the port A, port B, port C, port D. Okay, so this is the basically this is the thing. So okay, one question bit B is the give the internal block diagram of each and every block. Okay, so answer is it's very easy. The first one is timing generation, uh, and we have every internal block diagrams that I explained before. So yeah, second question is the provide the instruction set of microprocessing element, microprocessor, controller, IP core with clock cycle required or machine cycle required, memory required, flags affected, type of instruction based on addressing mode, operations, etc. This whole this whole instruction set was available in the data sheet. Okay, so this is the mnemonic operands, description, cycles. This is the 14-bit instruction word where this part is MSB and this part is LSB, and we have the status affected part. Okay, now this is the byte oriented file register operations. Okay, so I'm gonna explain some few operations. This add W and F uh, is defined by ADDWF F comma D, which has the cycle 1 and MSB 0, and the LSB is 111 DFF FFFF, and status affected is C comma DC comma Z. Like that, there are so many things. This is the decrement, this is the increment. For increment we use INCF, for decrement we use DCF. Okay, so this is a no operation, means no, NOP. Okay, So this is the rotate left through carry RLF FD. So this part is rotate left F through carry, and subtract is SUB. For swap we use directly SWAP, and exclusive or W with F, XOR WF. So yeah, this is the thing. We have more. This is the literal and control operations. Okay, the first one was byte oriented file register operations. Okay, okay. Let's go to the third question right now. We have, this is the third question, which is asked like, explain microprocessing element architecture. Okay, the instruction set architecture present in PIC32MM0256GPM064 is RISC architecture. Okay, what does RISC means? Reduced set instruction set architecture. The main idea behind is to make the hardware simpler by using an instruction set composed of a few basic steps for loading, evaluating, and storing operations, just like a load command. Okay, for storing operations, just like a load command will load data, store command will store the data. So, in the RISC architecture, simple instructions are used in RISC architecture. RISC helps and supports few simple data types and synthesizes complex data types. RISC utilizes simple addressing modes and fixed length instructions for pipelining. RISC permits any register to use in any context. One cycle execution time. The amount of work that a computer can perform is reduced by separating load and store instructions. This is the main point. RISC contains large number of registers in order to prevent various number of instructions with memory. In RISC, pipelining is easy as the execution of all instructions will be done in a uniform interval of time, that is one click. In RISC, more RAM is required to store the assembly level instructions. Reduced instructions need a less number of transistors in RISC. So this is the flow chart for the RISC memory. Okay. Okay, let's go to the fourth question right now. Correlate the microprocessing element architectures with the architectures discussed in the module 1. So what we have discussed in the module 1, we have discussed the von Neumann architecture and Harvard architecture in module 1, and the architecture in my microcontroller is RISC architecture. So even when we can correlate a RISC architecture with a Harvard architecture. So what are the points we can correlate? Reduced instructions need a smaller number of transistors in RISC. RISC uses Harvard memory model, means it is Harvard architecture. It's obvious, right? A compiler is used to perform the conversion operation, means to convert a high level language statement into the codes of its form. As we use less number of transistors, both the architectures very complex to design. Both RISC architecture and Harvard architecture uses only single clock cycle. The amount of work that a computer can perform is reduced by separating load and store instructions, and in the same way Harvard architecture have different locations. So these are the correlated points. Let's go to the next question, that is fifth. Elaborate register operation of microprocessing element. The answer is clear. CLR, set and INV, peripheral registers, HI and LO registers. These are some of the registers used in this. Okay, so we are gonna talk about CLR, set and INV registers now. Every IO module register has a corresponding clear, set and invert registers designed to provide the fast atomic bit manipulations. As the name of the register suggests, that a value written to a set, clear or invert register effectively performs the implied operation, but only on the corresponding base register, and only bits specified as 1 are modified. Bits specified as 0 are not modified. Reading set, clear and invert registers returns the undefined values. To see the effects of write operation to a set clear, the base register must be read. So let's go to the peripheral register right now. Yeah, what's the most common way is through peripheral registers. The hardware peripherals expose their functionality to software through a set of registers that are memory locations mapped to specific addresses in the processor address space, thus accessible via software. So peripheral registers must not be confused with CPU registers. They are not CPU registers. Everybody confuses with peripheral with CPU registers. Peripheral registers are mapped at physical addresses, not virtual ones. So in operating systems with the memory protection, Linux, Mac, Windows are accessible only from within the OS kernel. In a microcontroller environment, instead they are freely accessible since there is no memory protection. Obviously, if there is no memory protection, they can access anything, anytime, obviously. So this is the flow chart for the core register memory address. How does the memory address do with the communicate with the peripheral control registers and GPU security? So it's written that GPU pins outside of the chip, the area 16 pins of the GPU ports 1 and 2. Okay. So let's go to the sixth question. What is the sixth question? Explain the type of algorithm used for signed or unsigned calculations. Addition, multiplication. Oh, this is the Booth's multiplication used in multiplication. Okay. So the flow chart for the Booth's algorithm. This is pretty easy to explain. Okay. So yeah, first start. We have to assign a 0, q minus 1 0, m multiplicand, q multiplier, count n, and if q equal to 0 1, then it will go to 1 0, a equal to a minus m. If it is 0 1, then it goes to a equal to a plus m. If it's 1 1 or 0 0, then it's arithmetic shift right operation, count equal to count minus 1. Okay, so then if count is 0, yes, and if count no, then we have to repeat the operation again and again. Okay, so let's go to the seventh question. Find what type of control logic unit used and correlate its performance with the type of control logic unit in module 3 in the COA syllabus. Okay, so what is control logic unit? First of all, it is a component of computer central processing unit that directs the operation of the processor. It tells the computer's memory, arithmetic and logic unit and input and output devices how to respond to the instructions that have been sent to the processor. Custom logic unit. Applied custom logic unit without expanding the application size through the configurable logic cell and configurable custom logic peripherals, CCL and CLC. Okay, so now there is advanced peripherals. Core independent peripherals improve the system responsiveness and determinism. CIPs also allow the CPU to execute more complex tasks such as human machine interface, HMI control algorithms. Safety critical. Add robustness and reliability to your design by utilizing the built-in features of these MCUs, such as the window watchdog timer, WWDT, the cyclic redundancy check, CRC, and the fault detection using the event system. Okay, so let's go to the eighth question. Explain the memory management system in the processing element selected. Let's say its addressing capabilities, memory mapping technique followed. Find the advantage of the memory design and management techniques over the concepts given in the module 4 in COA syllabus. So yeah, what is memory organization? PCIe 32mm microcontrollers provide 4 gigabytes of unified virtual memory address space. All memory regions including program memory, data memory, SFRs and configuration registers reside in this address space at the respective unique addresses. The data memory can be made executable, allowing the CPU to execute code from data memory. Okay, so key features include 32-bit native data weight, separate boot flash memory for protected code, robust bus exception handling to intercept runaway code, simple memory mapping with fixed mapping translation, FMT. Okay, these are the features, and up to 32 kilobytes as RAM memory, SRAM, static. Okay, so multiple interrupt vectors with individual programmable priority, fail safe, clock monitor code, configurable watchdog timer on chip. Okay, now let's go to the multiply divide unit. The microactive UC core includes a multiply divide unit that contains a separate pipeline for multiply and divide operations. The pipeline operates with the in parallel with integer unit IU pipeline. Okay, and does not stall when the IU pipeline stalls. Okay, so explain the pipeline and the parallel processing capabilities of the unit and hazard management technique. This is the ninth question. Okay, so this ninth question, types of pipeline is divided into two categories: arithmetic pipeline and instruction pipeline. Arithmetic pipeline are usually found in most of the computers, and okay, the floating point operations, multiplication of fixed point numbers. Okay, here A and B are mantisas. Okay, this part is talking about this part, and compare the exponents, align the mantisas, add or subtract mantisas, produce the result. Okay, instruction pipeline in this stream is instructions can be executed by overlapping fetch, decode, and execute phases of an instruction cycle. Okay, what's the step one? Identifying the hazards, manual tasks, gravity, machinery, and equipment. Being hit by moving vehicles, falling objects, overexertion. These are the potential harm regarding to the manual hazards. Okay, so how to find the hazards? Inspect the workplace, make a list of the hazards you can find, consult our workers, review available information. This is all theory part. Information can be sent or sought from Workplace Health and Safety Queensland, industry association, unions, etc. etc. Okay, what's the step two? Okay, what's the step two? Assess the risk. Once a risk has been identified, a risk assessment should be conducted. Okay, so we have to ask the following questions to determine the risk factors. Does the task involve any of the following, like repetitive movement, sustained or awkward postures, or repetitive or sustained forces? Does the task involve long duration? Does the task involve high or sudden force? Does the task involve vibration? Okay, now let's go to the step 3, control the risk. Now we have found out the risk, we assess the risk, now we have to control the risk. How? By elimination. Example, automate the manual task such as using remote controls, deliver goods directly to the point of use to eliminate multiple handling. If multiple handling is done, then it will be a problem, right? So yeah, then we can go to the level 2, that's substitution, replacing heavy items with those of lighter, smaller and easier to handle. Okay, so with power tools to reduce the level of force required to do the task. Level 1, okay, this is isolation. We can also do the isolation thing and engineering thing. Example is mechanical lifting aids, provide workstations that are height adjustable. Okay, and level 3 is administrative, rotate the workers between different tasks, arrange workflows to avoid peak physical and mental demands towards the end of the shift. Personal protective equipment should be given to all of the workers. Example, heat resistant gloves for handling hot items, shock absorbent shoes for work on hard concrete floors. Then we have to review the risk control. How can we do it? The control measure is no longer effective. A change that is likely to give us a new different risk. New hazard should be identified if consultation indicates a review is necessary. Okay, so find whether the processor level parallelism is available in the element selector. Illustrate cache, coherence and protocol used for handling memory hit or miss. In my IC, LDM instruction with PC in the register list and without plus plus incrementals. Okay, so parallel processing is a method of simultaneously breaking up and running program tasks of multiple processors, thereby reducing the processing time. Processor level parallelism may be accomplished via a computer with 2 or more processors. Okay, so parallel processing is also called parallel computing. Cache coherence protocol for handling hit or miss. It is a uniformity of shared resource data that ends up stored in the local caches. Okay, when a client in a system maintains the cache of a system, a common memory resource, problems may arise with the incoherent data. Okay, so this is the flow chart for client to cache, cache to memory resources, and then again to cache. Okay, so we have to do this following. We send the address and read the operation to the next level of hierarchy. Wait for the data to arrive. Update the cache entry with the data. Okay, so advanced caching techniques are eliminate memory operation, decrease the number of misses, decrease the miss penalty, decrease the cache memory access times, hide memory latencies, increase cache throughput, increase memory bandwidth. Thank you so much. Hope you are understood.